Hello. Today I'll be presenting about step functions as a vector space. Before we get into the step functions, I wanted to review what properties the vectors within vector spaces have. First, there are three addition properties, namely the associative, commutative, and addition to zero properties. Then we have some multiplication properties, the associative property, multiplication by scalar 1, and the scalar 0. Finally, there's the distributive properties, where the multiplication by sums of scalars and sums of vectors would work as you would expect. We will be proving, roughly, that step functions are a vector space by looking at the real numbers, which trivially are a vector space themselves. We will start with the properties of real numbers, move on to the properties of step function outputs, since they are real numbers themselves, and this can show that the step functions themselves are vector spaces. For example, we have commutativity, where real numbers commute, from which we can deduce that the outputs of step functions commute, and by looking at it for all values of x, we know that the step functions themselves commute. Importantly, we must define the zero step function for multiplication by the scalar 0, where the zero step function has a value 0 at all values of x. And as one would expect, multiplying by 0 for any step function gives you the zero step function. There's some visual intuition for how the step functions act as vector spaces. For example, you know that adding two vectors should give you a vector back. So here, adding the green step function and the blue step function gives you the red one, as you might expect. Similarly, multiplying a step function by a scalar should give you another step function, and as shown in this visual intuition picture, you get what you would expect. In conclusion, step functions act as a vector space, and thus you can derive properties and add properties to the vector space as you would for other vector spaces. For example, as with real vector spaces, you can define a scalar product for step functions as shown. Thank you.